It says that an arrow of mass 50 gram traveling horizontally at 30 meter per second strikes an apple of mass 100 gram and embeds itself in it. So find the speed with which they began to move. Sorry. If the arrow penetrates to a depth of 10 centimeter, find the force of resistance of the apple. So initially the apple's mass is 50 gram. Its velocity before it hits the arrow's mass is 50 gram, and its velocity is 30 meter per second before it hits the apple, and the apple was stationary. So before the arrow hits the apple, the total momentum will be 50 times 30 plus 100 times 0, and after it hits the apple, the arrow hits the apple, the speed we don't know. What's the common speed with which they will start to move? Let's say it's v times the total mass, so that will be 150. So we get v is equal to 10 meter per second from that. That's the velocity with which they will start to move. Now we need to find if the arrow penetrates to a depth of 10 centimeter, we need to find the force of resistance. So it penetrates 10 centimeter, and as soon as it hits the surface of the apple, the arrow, as soon as it hits the surface of the apple, its velocity becomes 10 centimeter. So we know that we need to find how long it takes for it to penetrate 10 centimeters. So if we say s is equal to vt, this s will be 10 centimeter and v is 10 meter per second. So we have to change the unit. So that will be 10 over let's say 10 times 10 10 times 100 to convert it into centimeter as well, times t. So t becomes, so this is velocity in terms of centimeter per second, so t becomes 1 over 100 second. So that's the amount of time it takes to penetrate 10 centimeter into the apple. So F will be the force we need to find it, and F is equal to ma. M will be the mass of the arrow, and acceleration, in this case it will be deceleration because it will stop finally. So mass is 50, the arrow's mass, times its initial velocity was 30. Before, we have to start from its initial velocity. We have to find the initial we have to use the initial velocity and then the final velocity when it stops. That means after penetrating 10 centimeter into the apple, it will stop. So that will be 30 minus 0. I'm just forgetting the sign here because I'm considering it deceleration, so it's still positive. So this is final velocity minus, sorry, initial velocity minus final velocity, but this is deceleration, so I'm calculating like that, over 100. There is one more thing. This mass was in milligrams, so we need to convert it into kilogram as well. So we have to divide this one. This is 1 over 100, and we have to divide this one by 1000 because that's in kilograms. So 50 over 1000. We have to be very careful about the units always. Everything has to be, we are using MKS units. So this one will be 50 over 1000 in terms of kg because the mass was given in gram, and times 30, and this was 1 over 100. By mistake I wrote just 100 because this is time, and time is 1 over 100 second. So like that, and then times 100 basically. So we can cancel these 3 zeros there and we get 150, and the unit will be Newton. So that's the force of resistance applied by the apple. So we have to always be very careful about the units in these kind of problems.